Hey guys, Miss Altman here. I am just going to record myself working some of these word equations to chemical formulas problems because I know that they're kind of a struggle. So while I'm working on this, I'm going to make sure to have my polyatomic ion sheet and also my color-coded periodic table of the elements with all my charges on it. So I'm going to make sure to have those close by as we work on these things. So the first one that we are going to do is zinc bromide mixed with fluorine gives us zinc fluoride and bromine. Okay, so on Friday we talked about how there are 4 steps to doing these kinds of problems. First of all, we are going to just write down what we have. Okay, so we have zinc here and here. We have bromide, which of course is bromine. So we have Br and Br. And then we have fluorine, which of course is F. Now, right away, we have something that is going to maybe trip a lot of us up, but we have to make sure we remember. On our periodic table, we have 7 elements, and then hydrogen over here. We have 7 elements that are diatomic, which means in nature they always exist when, like with 2. Okay, so you're never just going to find one nitrogen. It's always going to be N2. Okay, and conveniently enough, those 7 elements make a 7, and they start at 7, with the exception of hydrogen, who's just over here living his life. Okay, so we have fluorine, which is one of those diatomics, which means that if you found this guy in nature, he's never going to be by himself. Okay, so we have to make sure that he has a 2 there. Same with bromine. He is part of that 7. Okay, so otherwise, we're ready to go with our next step. Okay, so our next step is we need to look at the charges of these elements to see if these molecules that we are trying to make sense. They have to be neutral. Okay, you can't have a molecule that has a charge to it. The only exception are these polyatomic ions. They get charges. If it's not on this list, that molecule can't have a charge. That compound can't have a charge. Okay, so first we're going to look on our color-coded periodic table for zinc. Now zinc has a +2 charge. So I'm going to go ahead and write that in underneath zinc. Okay, now I'm looking for bromine, and bromine has a -1 charge. Okay, and fluorine does as well. Okay, so now I've got my elements and I've got my charges. All right, excuse me. So I'm going to go back in now and rewrite this formula, this rough draft formula, taking into account these charges. Okay, so I have zinc bromide. This right here cannot work because their charges don't cancel out. So the way that I can cancel these charges out is if I have a +2 here and a -1 here, I need another -1 to cancel out that +2. Okay, so I'm going to need 2 bromines in this molecule. The way that we did it in class is you just take their values and you flip them. Okay, so we are going to give zinc this number, and we are going to give bromine that number. And so now we have a +2, and we have 2 -1s, and this cancels each other out. Okay, now moving on, this fluorine is not bonded to anybody, so we don't need to report what his charge is. So we're just going to leave it as F2. Okay, we draw our yield sign, and then right here, oh, it happened again. We have a +2 and a -1, so we're going to need to fix this so that this molecule is neutral. Okay, so we are just going to flip those values. We're going to put that number there and that number there, and it is going to be zinc F2. Okay, and then our bromine at the end here, again, is not bonded with anybody, so we don't need to report what his charge is. All right, so now I have this all written out. All the charges make sense. Now I just need to make sure it's balanced. Okay, so I have zinc, I have bromine, and I have some fluorine. Okay, I've got 1 zinc on the left, I have 2 bromines and 2 fluorines, and then over here I have 1 zinc, 2 bromines, and 2 fluorines. That is all balanced, so that means that this is the answer to this word equation. Okay, Let's maybe do one that's a little bit harder. Okay, so we're going to go to aluminum and hydrochloric acid gives us or yields aluminum chloride and hydrogen. Okay, so step one, we're just going to write down what we have. So aluminum is Al, hydrochloric acid is HCl, and that gives us aluminum again, chloride plus hydrogen. Okay, now, hydrogen is one of our weird diatomic guys, which means hydrogen will never be on his own in nature. So we have to make sure that he's got a friend, H2. Okay, so that was step one. Now step two is we need to go back in and figure out our charges for these atoms. So using my periodic table, aluminum has a +3 charge. So I'm going to go ahead and write that in. Hydrogen has a +1 charge. And chlorine has a -1 charge. Okay, so I need to go back and rewrite these molecules, or these atoms, in a way that makes sense using their charges. Okay, so again, this aluminum is not bonded to anybody, so his charge doesn't really matter right now. This molecule right here, hydrogen chloride or hydrochloric acid, those cancel out. So we're just going to rewrite him right there. Okay, now we do have a little bit of an issue here where our aluminum has a +3 charge and our chloride or our chlorine has a -1 charge. So we are going to flip and bring it down and write it like that. Okay, and then again, our hydrogen at the end here isn't bonded to anybody, so his charge doesn't really matter. Okay, so we wrote the elements, we figured out what their charges were, we figured out what the elements or what the formula should be, taking those charges into account. And now we just need to balance it. So we have some aluminums, we have some hydrogens, and we have some chlorines. So on the left, we have 1 aluminum, 1 hydrogen, and 1 chlorine. On the right, we have 1 aluminum, 2 hydrogens, and 3 chlorines. So I'm going to do this chlorine first because it's probably the biggest one that we have to mess with. It's the biggest difference, and this hydrogen at the end here is on its own, so he's going to be easy to fix regardless of what we do to it. So I'm going to go ahead and fix this chlorine first by just sticking a 3 right there, which makes us have 3 chlorines. It also makes us have 3 hydrogens. Okay, so my aluminums are fine, my chlorines are fine, but now my hydrogens are wrong. So I have 3 hydrogens on this side and 2 on this side. The best way that I know to fix that is to make both of them 6. Okay, so I need to put a 3 right here to give me 6 hydrogens here. And then I need to put a 6 instead of that 3 right here, which gives me 6 hydrogens. It also gives me 6 chlorines. So now we need to go back and reevaluate our chlorine situation. So if we have 6 chlorines on this side, we have 3 chlorines here, I can make this into 6 by adding a 2 right there. So that gives me 6 chlorines. It also gives me 2 aluminums, which is an easy fix by just sticking a 2 in front of that aluminum. Now my aluminums match, my hydrogens match, and my chlorines match. This is my final answer. Oh, let's do 2 more. Okay, let's do, this one's harder. Let's do this one, okay? So I have iron 2 sulfide plus hydrochloric acid yields hydrogen sulfide and iron 2 chloride. So first, I'm just going to go in and write down what I have. So I have iron sulfide, hydrochloric acid, hydrogen sulfide, and iron chloride. Now I need to go in and look at my charges. So iron is one of those weird ones that could be 2 different things, okay? But we don't really have to worry about that too much because they tell us in the formula, in the word formula, what charge this guy has. So we know that that is the +2 iron. So using my periodic table, I know that sulfur has a -2 charge, that hydrogen is a +1, that chlorine is a -1, and then I can just bring those numbers back over to this side over here. Okay, so I just moved these numbers over here to where they belong respectively. So now I need to go down and make sure that these molecules make sense. So this molecule, this compound works. This 2 cancels out that 2, so we're just going to move him down. Okay, this compound works. This 1 cancels out that 1. The end molecule is negative, or has no charge, excuse me, so we're just going to bring it down. Now over here we have a little bit of an issue, okay, because this is a -2 and this is a +1. So we need to make this compound 0 or have a neutral charge. So what we're going to do is we're going to flip whose gets what number, and we're going to end up with that. Okay, same thing over here. We are going to give this 2 to that chlorine right there to make the molecule be neutral. All right, so now we need to balance this. So I've got some hydrogens, some chlorines, some sulfurs, and some irons. So on the left, I have, looks like 1 of everything. And then on the right, I have 2 hydrogens, 1 sulfur, 1 iron, and 2 chlorines. So I'm going to start with this chlorine because I feel like the hydrogens are always really easy to do at the end, and these guys already match. So I'm going to fix these chlorines. So I have 2 chlorines over here, and if I want to fix that, I can just put a 2 right there, which gives me 2 chlorines. It also gives me 2 hydrogens, and with that, that equation is balanced, and that is your final answer.